Hello and welcome everyone to part 1 in the database modelling series, where we are looking at Enterprise Architect's Database Builder, which provides interactive connectivity between the model and the DBMS. This supports both the initial creation of a database and the ongoing update of tables, views, triggers and procedures, all from within the design model. This will be followed on with part 2 in the series, where we look at Enterprise Architect for modelling the conceptual, logical and physical layers and relating these to other aspects of the model. Although Enterprise Architect provides comprehensive support for data modelling from the conceptual model to the physical schema, the intense work of database engineering is on the physical level. This webinar provides an introduction to using the Database Builder, involving simple examples. As this webinar deals purely with the physical level data modelling, it should be noted that there are a number of different methods by which this physical model can be derived. In Enterprise Architect, these include by reverse engineering a DBMS schema into Enterprise Architect, by using an MDA transform from a logical model to a DDL physical model, or by manually creating a model using the DDL, IDF1X or information engineering modelling notations. For more information on these processes, see part 2 of this series of webinars. This webinar is focused on the interchange between the physical level model and the DBMS. We'll be working with a MySQL database using the freely available MySQL DBMS, and will derive our schema from a simple logical model that is available in the eaexample.eep repository supplied with Enterprise Architect. The topics we will cover include creating a model and connecting with the DBMS, creating a set of tables and exporting these to a DBMS, updating the database from the model, using the SQL Scratchpad for querying the database. Then we'll look at creating and working with tables, working with constraints, triggers and indexes, setting table relationships, and finally syncing the database and the model. Okay, so let's start with creating a model using the Database Builder. We'll start with a simple pattern. This is a starter to give an overview of a simple process and using a direct connection for syncing to and from the database. Let's start this by setting the perspective to database engineering. This will refine our selection of patterns to only show the database options. This opens the model wizard with some basic templates for creating a database model. For this exercise, we will select the MySQL basic pattern and create this. We can see this has been added to the browser. It is named by default as Database A. This is a starter for our model, but we want to interact with an actual database. Let's now open the Database Builder. In the left column, you can see the database model structure Database A that we just created, this being one of two with a Postgres Orders database builder under this. Each database builder group includes tables, views, procedures, functions, queries and connections. This being a simple starter, we have nothing under these as yet. For this presentation, we will be focusing mainly on the tables, queries and connections. When we look on the right side, there are a series of tabs with a number of features that we will cover in more detail. For now, it is showing the Columns tab. Having created the new database model, we need to create a new schema on the DBMS side, then set a connection to this. In terms of connections, we see that there are 3 default connections already defined, including the development, test and production connections. To create this new schema, we first want to create a connection to the system database, that is, to allow us to create the new schema for our shopping cart database. Once that is created, we can come back and use the developer connection to connect to this new database. So, let's add a new DB connection from the context menu. We give it a name, MySQL, the core database. Double-click on it to open the properties. And we are prompted with the options for creating a connection. In this case, let's use the direct native connection. We now set this connection to the system schema, MySQL. Select MySQL as the DBMS type. To give this a description name, MySQL. For the new server, in this case it is localhost and default port. For the database name, we set the system schema, MySQL. And for the user, we kept this as a simple default admin user with no password. On testing this, we see that it is all OK. We set this as the active DB connection. Now to create a new schema, our shopping cart database, we open up the SQL Scratchpad, type in a create schema command to create the new database. Just to confirm this, let's run show database. We can now see our new shopping cart database has been created. So let's now set up a specific connection to this new database that we just created. You can see that by default there is a series of 3 connections supplied. This is to enable easy swapping between versions. For now, we select the first connection, the dev connection, to set up a native connection to our new shopping cart database. We give this a description name, shopping cart, select MySQL as the DBMS type, the server name, in this case localhost, and the default port. The database name we set as our newly created shopping cart. And the user, again, we kept this as a simple default admin user with no password. We test this, all is OK. Now we set this dev connection as the active DB connection. At a later point in the development, it is very handy to be able to swap between the development and the test database for checking before deploying this to a critical production server. Just as a starter, let's define a simple table with some basic fields, which we'll later expand on with multiple tables from an example model. For now, let's create a starter for the user account table in the shopping cart. So from the tables context menu, let's create a new table. We give it a name, account. Then in the columns, let's create some basic columns. First, let's add an account ID. We set this to be of type int and define it as our primary key for the table. Now we create a name field and set its length to 40 characters. Then we give it a delivery address and leave this as 50 characters. That will do for now. We can cover more later. Having looked at the Constraints Index tab, we see that given we had created a primary key, this has created an entry PK account of type PK. This contains the details required for generating the script for the primary key index. We'll go over the features of this Constraint Index tab later. Let's expand on this. But rather than create each table and column, we will work with a set of tables derived from a logical model accessible in the EA example model. From this, we will create in the model a set of MySQL tables using an MDA transform from a class model. We will cover in more detail this general process of using MDA transforms for creating data models in part 2 of this series. In the EA example model, we find the abstract class diagram that covers the logical structure that we want for our database. Using this as a logical model, we can apply an MDA transform to generate out a set of tables into Database A's tables package. Here are the generated tables that are derived from this. We refresh the database builder to see the newly created tables in the database browser. On selecting the Accounts table, we see that in the Columns tab view, we have the detailed configuration of each column in the table. This is generated from the logical model, an equivalent set of fields that we created earlier on. Having created a MySQL model of our simple shopping cart example, we are now ready to export the table set into this new database that we created at the start. This export process is covered in 2 stages. Firstly, we generate the SQL commands as DDL script. Then we execute that DDL script. Using the ODBC connection, this executes the script on the database that we are connected to. So in this case, we want to generate out a set of DDL scripts to be run from Enterprise Architect to create the table structure in our new blank database called Shopping Cart. To generate this script, we check that we have the active database connection that we set up earlier. We then right-click on the Tables group and select Show Differences. This will open the Database Compare tab. Given this is just for creating a new set of tables, we simply click on the Set Synchronize button. so that all these new tables are set to be generated as script. Then we click on the Generate DDL button. In the Execute DDL tab, the generated scripts are now in the queue, and the Create table for the account table is displayed in the Script tab as shown. Now let's execute this generated DDL via our connection to the shopping cart database. To do this, we click on the Execute All button. This executes the scripts on the DBMS server. It runs through the queue at the top and lists the results in the bottom pane. Having created the new tables, we can now use the SQL Scratchpad feature to check and confirm these tables were created. Hence, we are eliminating the need to open up other applications. For a simple example, we can run a SQL statement to check that our account table has been generated from the script. You can see by the fact that the column names are returned that the table has been created. There are no rows as yet, but it is returning the column names. Having run over the steps to generate the tables for a simple model, we can now move on to the round-trip process of making modifications to the model and then updating these in the database, as well as making changes in the database, then updating the model. A core feature of the Database Builder is its support for round-trip maintenance of the DBMS, with direct support for updating existing tables on the DBMS, as well as the option to query these from within Enterprise Architect. When maintaining a DBMS, a common scenario is to use the Database Builder to make changes to your development model, apply these changes on the latest test DBMS, run your testing with the sample test data, then update the production DBMS after passing the tests. For both of these update processes, test and production, you can perform a database compare between the model and the DBMS. This generates a set of differences. Then using these differences, you can set changes either in the model on the DBMS side or select the updates that you require, then execute the commands to update to either the DBMS or to update the model. In this section, we'll create a basic table and its relationships using the Database Builder. So given the database is for online sales, let's create a table for our wholesalers. First of all, we select the Add New Table context menu option, give the table a name, Wholesaler. On creating the table, the details of each field can be edited directly under the Columns tab. So we click on the Add New Column field to create a new column. Let's put in Wholesaler ID, set its type to int, and set it as the primary key. Note that on creating a field set as a primary key, there is an automatic creation of a primary key constraint. Then in the column group, we set the order numbering as true. On viewing the Constraints Index tab, we can see that when we created that primary key, it is set the PK Wholesaler primary key to Wholesaler ID. Now for two more fields in this table, we give it a company name column, leaving it as varchar 50. Then a contact details column, leaving it as varchar 50 as well. Hopefully that gives us a simple model for a wholesaler table. Now, given that any stock items are supplied by wholesalers, let's look at setting up a relationship between the wholesaler table and the stock item table. Although the table relationships, foreign keys, can be set in diagrammatic form, when using the Database Builder, you can simply create these on a child table, which makes an implicit foreign key relationship to a parent table that you select. To do this, we right-click on the child table, stock item, and select Add New Foreign Key from the context menu. Then we select the parent table, wholesaler. We are now prompted with the details of the foreign key relationship, as shown. As you can see in the properties, there are a variety of options, including on delete and cardinality settings, but for this scenario, we are happy with the defaults. In this case, the default has the parent as wholesaler on the left and the child as stock item on the right, which is what we want. So we simply click on OK. The relationship is added to the Database Builder hierarchy panel, as we can see. Now if we open up the diagram, just to do a bit of housekeeping, we will bring the wholesaler table into the same package, the DDL package, that was created with the MDA transform. This is transparent, but it's worth keeping these together in the browser. we add our new wholesaler table, we can see the relationship in the diagrammatic format. Now we can see that it has created the connection showing the primary key and foreign key relationships. There are a number of options for setting constraints, triggers and indexes. So let's run over these by going back to the Database Builder view. We select our new wholesaler table. Using the Constraints Index tab, we can set any number of indexes, constraints and triggers for each table. Let's look into one of these, that of creating our own indexing. In this case, let's simply set up an index for the company name. So, we go to the Constraints Indexes tab, type in our name for a new constraint index, company name index. In the type field, you can see we have a range of options, including primary and foreign key options, indexes, check constraints, unique constraints and triggers. In this case, the primary key was set earlier when we were simply setting the column PK tick box. And regarding the foreign keys, we've already covered one of these earlier for the stock item. So, let's set an index. In the lower pane, we can select what field to index on. So in the available columns, we double-click on the company name to get this placed in the involved columns. We can also set the constraints as unique or clustered. Selecting, say, trigger, you can see the options in the bottom pane. Trigger, trigger time, trigger event, and the editor to lay out your trigger statement. So in this case, let's just select index in the type field. Now we have the index defined. Hopefully this gives you a quick overview of creating a table, defining columns in the new table, setting column properties like auto number, setting up primary and foreign key relationships, checking the diagrammatic relationships, and setting constraints. Having made the changes to the model, we can now update the database in the DBMS with these changes. A common scenario with this is to update the developer DBMS before altering the testing or production DBMS. To ensure we have access to this, we check again that we have set our current connection to the developer DBMS by setting it as the active DB connection. To start the process, we right-click on the Database A group and select the Show Differences option. In the Database Compare tab, it displays the differences between the model and the selected database. As you can see, under the Live DB column for the wholesaler, we have a blank. This is indicating that this table exists in the model, but is not in the developer database. As a starter, we will run through the first two update processes as simple transfers each way. For this scenario, we will just deal with updating the model to the database. To have a quick look at the Actions options for our new table wholesaler, this is preset to no action. Using the Action drop-down, we see the option to create it in the database. For simplicity, we are just updating the model to the database, so we can just click on the Synchronize All button. This sets all the tables from the account down to transaction as a one-way update to the database. We will reset this and run through these in more detail using specific actions to show you the options that you can take for cases where a more precise process is required. With the wholesaler selected, we drop down the action field and select Create Wholesaler. As we're not doing a Synchronize All, there is one other modification that we made. We set the stock item wholesaler foreign key. On selecting that, we see in the bottom pane there is a blank against the foreign key stock item wholesaler. So we do need to set this to update the database as well. The Synchronize All would have covered this. So now we generate the SQL commands by clicking on the Generate DDL button, then move to the Execute DDL tab to view the proposed changes. On going through each of these, we can see the SQL to be executed. The top ones involve creating the foreign key for the stock item, and the latter ones creating the wholesaler table, columns and constraints. To execute these SQL scripts in the database, we simply click on the Execute All button. We can see this executes the DDL scripts and gives us a listing on the commands as responded to by the DBMS. Now to check that the tables were added to the database, we can run a simple SQL statement to query the new table. We just type in a select query to return all the fields in that table. Of course, as yet, there are no rows of data to be entered. So, what it shows is just the column headings, but that does confirm that the table exists. Now we can save this query in the model for later use using the Save As button. Then we can do a quick SQL insert and add a new entry to the wholesaler table. This gives a response as one row added. Let's save this SQL query for later use. Then we run the simple select that we saved earlier by easily restoring this to the Scratchpad by right-clicking and editing it. This is all to check that this row was added to the table. We can now see the details of the row we just inserted. In the earlier process, we updated the database with the new items from the model. When you have situations where the source of the change is in the database, with the Database Builder, you can easily update the model using the Show Differences option. Let's make a change to the database with a simple alter statement that we can run from the Database Builder. We see that we have no mobile phone or cell phone column for the account. So let's add a column to the table on the database side. This just adds one new field to our table. By using a simple SQL statement, we can check that it has been run and now exists on the database side. So we can now see that the column Mobile has been added to the Accounts table. Now, on the model side, let's look at updating the model by doing a compare. Firstly, we run another compare by selecting the Show Differences option from the context menu of the database package. In the Database Compare tab, we select the table we just changed, Account. In the bottom tab that covers the details for this table, we see it now shows the alteration as a blank in the EA column, and so is ready to accept an action. We set the Account table action to import the difference into the model. Then we click on the button to update the model. You can now see the update to the Account table in the model as shown. Let's now explore a more common scenario where you have an existing model that was generated out to the developer database. A copy of this, pre our wholesaler edition, was then passed on to the test DBMS. But in the interim, there have been changes done on the structure in the test database outside of Enterprise Architect, and there were design updates to the structure in the model within Enterprise Architect. So, in short, you have changes on both sides, the model and in the DBMS. Okay, so let's run through the options for resolving this by syncing both of these changes in the model and in the database. First of all, we will change the connection to test, which already has an ODBC connection to our second database. From the context menu and on the database A, we set test as active. Back on the root of database A, we use the context menu to select the Show Differences option. On the database compare pane, we see the wholesaler table is yet to be created. It is blank under LiveDB. There are two tables in the LiveDB that are not in the EA column. Okay, so that is on the table level. Let's take a look in a specific table on the column level. Opening the account table, we see a similar set of differences, some on the EA side and some on the LiveDB side. In this case, closed is defined in the model, not in the database. Delivery postcode is defined in the database, not in the model. Also, we see that the actions column for all of these, they are all set to no action. The action column is key to how we want to proceed. Clicking on the actions for one table, account, we see no action, update the table in the database, update the table in the model, customize and unpair. Having a look at the closed in the lower pane, we have the key options, no action, add closed, delete closed. Of course, with no action, this will leave both the model and the database as is. For add closed, it would generate the script to create the column in the database, or if we use delete closed, it would delete it in the model. For the new table, we have the options to create the table or remove it. We can change the wholesaler to create wholesaler. With the wholesaler selected, we can see in the bottom pane the actions required, including creating columns and constraints. Having viewed the options for change, let's now reset them. Now let's take a look at the two buttons options. With the Set Input All button, the LiveDB is the source of truth. So by default, it is set to update the model to whatever is in the LiveDB. When we use the Set Input button, we can look at the two levels of change. In the top pane, you see that by default the changes on the DB side will be updated in the model, but the new table in the model will not be updated to the database and so will be deleted in the model. In the Details pane, for the account table, the new database columns are set to be added to the model, but the new model columns, like close and history, are set to be deleted. These can be changed to cover your needs, but in this case, let's take a look at the Synchronize All button. When using the Set Synchronize All button, we are setting the model to be the source of truth, so its default settings are for updating the LiveDB to whatever is in the model. In the top pane, you can see that by default the changes on the model side will be updated in the database. The new table in the model wholesaler will be updated to the database, and the new tables in the database, author and stock item author, will be deleted in the model. In the Details pane, for the account table, the new model columns are added to the database, but the new database columns will be removed from the model. So in this case, let's do a Set Synchronize All, then go through the items and change any drops or deletes to adds. Let's start with the account table in the Object pane. For the items in the Details pane, we change these from drops to adds. On the line item, we set these to adds. Then for order, shopping cart and stock item, these are okay for the database updates, so we leave them as is. For the transaction table, we set the new columns in the table to sync back to the model and add the foreign key. For the author and stock item tables, we set these to be imported into the model. You can now see that on the top pane that these changes are logged as customized actions. So now we can generate the SQL commands by clicking on the Generate DDL button. Then we move to the Execute DDL tab to view the proposed changes. On going through each of these, we can now see the SQL to be executed. The top ones relating to creating the foreign key in the stock item, and the last ones creating the wholesaler table, columns and constraints. To execute these in the database, we simply click on the Execute All button. We can see this executes the DDL script and gives a listing on the commands as responded to by the DBMS. After running through the syncing process, we can check this by doing another import from the LiveDB, and from this see the tables on the database side that are being added to the model. We can further check these updates by doing another Show Difference. Running down the tables, we can now see that the EA column and the LiveDB column in both panels are showing the same details. However, looking at the column count, this is giving a count of the differences, so we do need to check these. That is by opening up the bottom pane to view any that show a count. On running through these, we can see that most of the differences are minor, in that they are either a default of null that was set by the database but not on the model, or the column position is different between the model and the database. Given there were new tables created in the database that were updated in the model, we can update the model diagram to reflect the new tables that were added. So let's open the original diagram of the model, the one that we created back in the MDA transform that was from the logical to physical model. Then we updated after setting the table relationships. We know the new tables were related to the stock item table, so we select it and use the insert related elements to add the new related tables. We do the same for the stock item author to include the new author table on the diagram. What we have covered is a brief look over the key features for checking and updating both the model and the database. The processes used in this demonstration would of course need to be more regimented when doing any updates to a live database, but hopefully this has highlighted some of the core features available for this type of process. With the simple processes covered in this section, you've been able to make alterations to the table and update these in the database, make alterations in the database and update these changes in the model. Check the alterations by posting queries to the database and viewing the results in the model. Then doing a two-way sync between the model changes and the database structural changes. In conclusion, hopefully this has given you a good overview of the scope of Enterprise Architect's Database Builder for creating and maintaining the DBMS structure, that is, to meet the background development of your application code and design. Using the Database Builder, you can keep a consistent source model associated with both the test DBMS and the main working DBMS environment, and be able to work with both of these directly from within Enterprise Architect. In part 2 of this series, we will cover other features useful when doing database modeling, including more detail on using the DDL scripts, MDA transforms, and methods for creating, checking, and direct relationships between tables, columns, elements, attributes, and user interface fields. For more information on the Database Builder, see the Enterprise Architect online help topics under Modeling Domains, Information Engineering, Creating and Managing Data Models.